So what we have with this problem is determining whether a function is odd, even, or neither. And so at the bottom here, I'm just going to write down the definitions of odd or even, because I think that's going to help us out. So for an odd function, the algebraic definition is f of negative x is equal to negative f of x. Oh, it's frozen, my bad. F of negative x is equal to negative f of x. For an even function, we have f of negative x equals f of x. So that's the algebraic definition. Graphically, so this is algebraically. Graphically, you are symmetrical about the origin for odd functions. Symmetrical about the origin, so about 0, 0. And for even functions, you are symmetric about the y-axis. Symmetric about the y-axis, okay? And I think if we pull up Desmos, it'll be pretty easy to see what functions are odd, even, or neither. So let's look at the absolute value of 30x, okay? Desmos. We are going to find the absolute value of 30x. All right, hopefully we can see this just graphically, this function is symmetrical about the y-axis. And you graph it for yourself as well. You can follow along with Desmos. All right, but this graph is symmetrical about the y-axis, which means that it's, and let's look at this graphically. Look, 1 is 30, negative 1 produces an output of 30. 260, negative 260. Negative 1.5, that's an output of 45. 1.5, also an output of 45. Keep on looking at this pattern. 5, 150. Negative 5, 150. That's what I mean by f of negative x is equal to f of x. Whatever if your input value is negative, then the same input value that's positive is going to have the exact same output for all values of the function if the function is even. So I can go to f of x is equal to the absolute value of 30x and say this function is even, right? Oh, let me go back. And the easiest way I think I can prove that the function is even is that let me go just back to negative 1, negative 2, 1, and 2. So I have 0, 30, 60. Is that I have negative 1, negative 2, 0, 1, 2. I have 0, 0. Oh, and let me do negative 1, negative 2. But I have 0, 1 is 30, negative 1 is 30, negative 2 is 60, negative positive 2 is 60. So this is even. All right, then I have, next one, 10p over p squared plus 4. In Desmos, I just put in 10p, or I'll have to do 10x over x squared plus 4. All right. And hopefully you should see this is an odd function. I have 1, 2, -1, -2. 2, 2.5, -2, -2.5. So now, if you're in comparing positive and negative inputs, the output has the same absolute value, but one's positive, the other's negative. That means this is symmetric about the origin. So this is an odd function, and the best demonstration for this is you have -2, -2.5, +2, +2.5, -1, -2, +1, +2. Put the function into the calculator. If this is true for all x and y values, where you have the f of negative x, think about it, f of negative x equals negative f of x. And that's what you're doing, all right? So this is odd. So try the next one, -4t cubed minus 8t plus 5. Tell me whether, graph this in Desmos and tell me whether this is odd or even. But you have to use 4x, so that's -4x. -4x minus 8x plus 5. -4x cubed minus 8x plus 5. All right, so yes, Maya. Oh, you need prep sheet 2. So this is we're on all right, so once again, now we're focused on math. So you got to make sure that you have Desmos on your screen. -4x cubed minus 8x plus 5. Okay. Is this function symmetrical about the origin? All right. Is the function symmetrical about the origin? No. Is this function symmetrical about the y-axis? So I'd say it's neither. Let's look at the inputs and outputs. -253 to -43. From that information alone, you immediately know the function is not odd or not even. Because you have inputs 2 and -2 have outputs that don't have the same absolute value. If this was an odd function, it could look like x cubed, right? Now this is symmetric about the origin, and it has it so you have -2, -8, 2, +8, -1, -1, 1, +1. That's an odd function. So for this problem right here, I know this is neither. I think this is the fastest way to do it. This is neither because you have -253 to -43. Immediately from there, you see that these don't have these are not the same absolute value. They have different absolute values. y equals x squared. All right, do this without my help. All you have to do is plug the function in Desmos and look at the table. You should be able to tell pretty quickly whether it's odd or even. And you should be able to look at it graphically. Reflection across the y-axis, symmetric about the origin. So what about y equals x squared? Even. Excellent. It's even. -2, 4, +2, 4, -1, +1, +1, +1. That's the characteristics of an even function.